Let's now introduce the settings and procedures for the transformation method. Suppose that we want to draw a random variable x with some distribution CDF large fx. Further, suppose that we already know that by applying a transformation on a different random variable y, we call that transformation h of y, it can give us a random variable with distribution fx. In other words, h of y has the same distribution as x. Then, in order to draw random samples of x, we can exploit the relationship between x and y in our sampling procedures. Specifically, to draw n samples of x, we can do the following. Step 1, we can draw random samples of y, y1 all the way up to yn. In step 2, we can apply the transformation h. Specifically, for each I between 1 and n, we set xi equal to h of yi. And the samples that we obtain in this way, the xi's, will follow the same distribution as the original x. This method, also known as the transformation method, works because we know that h of y and x are equal in distribution. In other words, they both have the CDF large fx. Therefore, if we sample the y's and then apply the function hy, the samples will have the same distribution as the original x's. In this case, our y doesn't have to be univariate. It can also be a multivariate random vector. For example, y can be a vector of two random variables, y1 and y2. They might be independent or they can be dependent. And in this case, an example of the h function applied on bold y, the y vector, will be y1 over y2. So that's the ratio between these two. Another remark is that you can think of the inverse CDF method we introduced last time as a special case of the transformation method. Specifically, this is the case where our y is uniform 0, 1, the standard uniform random variable, and the transformation function we apply, h of y, is the inverse of the CDF, that is fx inverse. However, instead of looking at the inverse CDF method, which is a transformation method, but we have to still use the CDF to get the inverse, let's look at a few examples of the transformation method where the transformation doesn't actually involve the CDF of the distribution.